Hello students, as you know we have been solving the JEE main paper of 2017 and we are into the physics section. Now this is the question number 35 of set D. In this question we have been given a rod which is pivoted at this point and is free to move along this axis. And we have been told that we have been asked to find out the value of angular acceleration of this rod if it is free to move along this axis. Now the question is very clear. अगर अब हमें इस क्वेश्चन के अंदर ये पूछा जाता है कि इस एंगुलर एक्सेलरेशन रॉड का कितना होगा, तो वी नीड टू अप्लाई टू प्रिंसिपल्स ओवर हियर. फर्स्ट वी मस्ट फाइंड आउट व्हाट आर द फोर्सेस दैट इज कॉजिंग दिस रॉड टू मूव इन दिस प्लेन and due to these forces what will be the angular acceleration. First I need to find out what are the forces that are acting on this rod. The first force is the weight of the rod itself and which is equals to mg. This is fairly simple. I shall replace that m by mg as we have been given the mass to be capital M. So the capital mg is the weight of the rod which is acting in the downward direction. Now there is another force which is acting at this point of the rod, which is, let's say, reaction R. We are just assuming that it's acting in this particular direction. This is just an assumption that we have made. अब मुझे ये फाइंड करना है कि इस रॉड का एंगुलर एक्सेलरेशन कितना होगा. अब मुझे एंगुलर एक्सेलरेशन अगर पता करना होता है तो मुझे पता करना पड़ेगा कि इस रॉड पे टोटल टॉर्क कितना लग रहा है. और जैसे कि हमको पता है कि टॉर्क निकालने के लिए हमें एक पॉइंट अज्यूम करना पड़ेगा जिसके अबाउट हम टॉर्क निकालेंगे. नाउ द assumption here is very simple, is fairly simple, as we are not very sure about the nature of the reaction R which is applied from the ground on the R. Why don't we just take this point P to be the point of consideration of torque? इसका मतलब ये कि अगर मैं P के अबाउट अपने टॉर्क को फाइंड करता हूं, मुझे पता है कि R जो है इसके कारण जो टॉर्क P पर होगा that would be 0 because it is the origination of this force. So my R would be definitely 0. तो इस R के कारण जो टॉर्क होगा वो डेफिनेटली 0 होगा. तो the only force that would produce a torque about this point P would be the weight. Now let us go and find out the torque of this. So I know my torque would be nothing but equals to force into the moment arm, that is R. I know my force is nothing but mg. Now I have to calculate the force which is perpendicular to this moment arm. If I take this as my moment arm R, I need to find the force which is perpendicular to this, which is in turn this. Now this is theta, this would be theta, and this would be mg sine theta. So my force is nothing but mg sine theta, and my R, as you can clearly see, is half of the rod. This is my entire rod. This is the center of the rod. So this is L by 2. So my R would be nothing but equals to L by 2. Now I know that the formula for angular acceleration, if my torque is given by I alpha. Now, if I just substitute the value of I can get the value of alpha. So what would be the value of I? We know that the value of a rod, the value of moment of inertia of a rod about any of its end point is nothing but equals to ml square by 3. So this is another important consideration that you must have in mind while putting the value of I. Now, if I substitute this value in this, I get my final equation to be mg sine theta into L by 2. I must write as small l as we have been given that the length of the rod, that the total length of the rod is small l, and that is equals to I, which is equals to m l square by 3 into alpha. I need to find this value of alpha. I just need to solve this. M gets cancelled, one of the L gets cancelled. So my alpha is nothing but equals to 3g sine theta by 2L, which is my final value of the angular acceleration in this case in which the rod is free to move around this point. So I hope you understood the entire solution and I hope you got this right. So why don't you hang on to this channel? I want you to subscribe to our channel to get more updated video solutions.